name is hello.
Prasad Ahire will now start his optional activity on household appliances. Yes, you can start, Prasad, now.
Hello. My name is Prasad Ahire. Now I'm going to show you optional activity number 1 on household appliances. So my household, I have taken household appliances that is of inverter circuit. My contents are I will introduce to inverter, and I will also introduce to the main components of the inverter circuit board, that is main, and I will show the opening of my inverter which I have home appliances taken, and also give a detail about circuit board and it's working. So this is so what is basically inverter? We use inverters as an emergency backup when there is a power outage. So basically, inverter converts the DC power into the AC power with the help of the battery and other components. And it turns on the electrical appliances when the main supply is off. And it also feeds the critical loads that cannot lose power even for a short period of time. When in any important function, we use the inverters. So because at that time of functions, we cannot afford the loss of power. It also give a clean power. So these are the basic local inverters in the market. This is it is a CFL inverter. I'm going to show you the opening of an CFL inverter, local CFL inverter. So my name is Prasad and I'm going to show you the circuit board of inverter as an optional activity number 1. So this is an CFL inverter. So these are these components. Here is the name of that company. Now I will open it. I have already opened to save the time. This is circuit board. This is transformer. The main part is battery is missing because due to the lack of availability of materials. Circuit board, a transformer. This is cell type transformer, and this is LED for indication of the battery status. And now I will remove the transformer and the circuit board. Shell type transformer, and its connector. This is winding. Now I will remove the circuit board. This is circuit board. This is connections. See these capacitors, transformers, relay, resistors, IC pins. This is transformer, shell type transformer. These are capacitors. This these are resistors. This is resistors. Their value is approximately 3 kV. 3 kV. This is IC. This is capacitor 35 volt capacitors. This is pin socket. Then we got this LEDs which indicates these are connectors of LED. This is transformer and this is circuit. Now I will show you the main components in detail. The main components of an inverter are IC pin, transistor, filters, and transformer. So this is a basic circuit. Now IC pin. The main IC pin is used is SG3524N. It is of 16 pin IC. It is an integrated switch regulator circuit. It is the main, that is the main point. It is heart of the PWM inverter circuit. It because this is heart of PM circuit because it corrects the output voltage against the variation in any output load. Means there is there is any variation of the output load, this pin will correct its output voltage. In our circuit, this is the pin. This is SG3524N IC pin. We have 16 pin. You can see this. It has 16 pin. Then is transistor, that is MOSFET. So in our circuit, the MOSFET means metal oxide semiconductor field effective transistor. You will know that that is common. And the MOSFET used here is that is LM317T. This is our MOSFET, and it is with the structure this. Here is the MOSFET. It controls the it controls the means it is used to stop the charging of the battery when the battery is fully charged. This is our filters. So here mostly RLC filters are used, and these filters are used to limit the passage of harmonic components. And harmonic components increase the losses, And in here, this in our inverter, this is, filters are used. These resistors, these capacitors, transformer. In these two transformer are used. This one is for input supply, and this one is for converting the DC into AC. Means it's not DC. It will for it is both. This is step down and this is step up transformer. The orange one is step up transformer, and it is a, then another one is a step down transformer. So this inverter transformer are used where the DC power supply is available. These both are shell type transformer. As you can see, the shell is outside and the winding is inside. The shell is outside, the winding is inside. See this. This is a step up transformer. The circuit board. I will explain the circuit board. This with the laser. This one, this and this four. There are four connectors. It is this connector is used for short circuiting or completing the circuit of this whole circuit. This connector is used. This these connectors are used to connect the LED, the other components of our LED. It is also a short circuit connector, and this connector is used for the transformer. The main transformer is bigger one transformer is connected to this connector. These both terminals are for battery connections. This is our type of transformer. This is relay. This diode are used. These four diodes are used to rectify. Here is our MOSFET. Here is our IC pin. And here is a 35 volt 100 35 volt 100 microfarad capacitors. This. So I will explain the working. First of all, we have to connect these two terminals and these two terminals with the help of connectors, other connectors, joint short circuit. Then the R circuit will complete. Then we have to connect the transformer to this 3 pin. Then when the input, the step down transforms, step down the voltage, and this from the this is the relay to protect the any damage to the circuit. Then after the transformer, the supply is given to this relay, and after this relay, this they are given to these four diodes. This diodes rectifies the supply into the pulsating DC, and after this pulsating DC, it is given to the filter. This capacitors, this capacitor filters the supply and into the DC, and this then the DC is given to the then DC is given to the battery and it charges. Then after the supply is out, is the from the battery the supply is taken and given to the circuit, and the circuit and with the help of the transformer step up, then the supply is given to the our appliances.
Okay, very good, Prasad. You have just explained in a very excellent way, and